We're going to look at some examples of implicit differentiation. So when you can't solve for the y because it's not a function, you treat y as implied within every y is some function of x. So when you take the derivative of y, you are evoking the chain rule, and you're going to have to times by the derivative of y, which is dy dx. Okay, so let's get started here. So the derivative of x with respect to x is just 1 plus, and then we have a product rule here. We have 8x times y. So I'm going to do first derivative of the second. So the derivative of y is 1 dy dx plus the second, which is y, and the derivative of the first, which is 8, equals derivative of x squared, is 2x, plus the derivative of y squared is 2y times dy dx. Because it wasn't x squared, it was y squared. So I have to use the chain rule. Okay, now you're going to put everything with a dy dx to one side, and everything that doesn't have a dy dx in it you can bring to the other side. So we're just collecting like terms. So we have 2x plus 2y minus 8y minus 1. So I just rearrange there. And then I'm going to factor out a dy dx. And I have 8x minus 2y. And then over here, let's see, what do I have? 2x minus 6y minus 1. And then I'm almost done here. Let's try that again. And then I have dy dx equals 2x minus 6y minus 1 over 8x minus 2y. Okay, and that's my answer. And this can't be simplified because I can't factor a 2 out of everything because of that minus 1 there. Okay, so let's try another one. Okay, so again, I have a product. So first, derivative of ln y is 1 over y times dy dx. Again, because it's not ln x. If it was ln x, it would be 1 over x. So that's first d second plus second, derivative of the first, which is just 1, plus the derivative of e to the 5x is e to the 5x times 5, plus the derivative of sine is cos y times dy dx, and then the derivative of 7 is just 0. Okay, so again, I collect things with the dy dx, so I have x over y dy dx, and plus cos y dy dx. And then I'm bringing everything else to the other side, so I have minus ln y minus 5e to the 5x. I think I got everything there. And then I'm going to factor out a dy dx. And I get dy dx is equal to minus ln. And then this could be simplified. So I shouldn't need 2 fractions. But we'll just leave it like that. Okay, so let's try one where we find the second derivative, and hopefully this is not too messy. Okay, so the derivative of x squared, 2x is 2x. X squared is 2x. The derivative of y squared is 2y times dy dx. So every time you take the derivative of y, it's a chain rule situation, and you times by the derivative of y, because you don't know what y is, what function of x it is, because you haven't explicitly solved for it. And then equals 0. And then dy dx, we bring the 2x over, divide by 2y, and then this cleans up. And you really want to clean it up if you're going to find the second derivative. Okay, so this is the first derivative. And now we're going to find the derivative of that. So the derivative of the derivative is the second derivative. And then you have a quotient rule here. So the bottom times the derivative of the top minus the top times the derivative of the bottom. So the derivative of the bottom is 1 dy dx all over the bottom squared. And then we're just going to clean this up. So we get minus y plus x. And your dy dx we've already solved for, so we're going to replace that. And then over y squared. Okay, so I'll clean this one up. So we could get a common denominator on the top. So we could have y squared over y plus, oh, it's actually a minus, isn't it? Minus x squared over y. So again, I just multiplied this by y over y, a form of 1, to get the common denominator. And then all over y squared. And then this is minus y squared minus x squared all over y, the common denominator. And then I'm going to turn this second divide sign into a multiply, and 1 over y squared. And then I get minus y squared minus x squared all over y cubed. And this is the second derivative. And that's the second derivative, all in terms of x and y. And if you don't replace this right here, then it would be in terms of x and y and the first derivative. So you should replace that with in terms of x and y. Hopefully that helped.